For each of the following, we want to find f of g of x. So again, some composition stuff here. So I have f of x equaling 2 to the 8x. I have g to the x equaling log base 4 of x. So um, first I'm going to do f of g of x, which is f of the log base 4 of x, which means I'm going to go to the function f of x and replace each x with log base 4 of x. So I get this. Now, if I had some way of having a 4 down there and as the exponential base, and it was right next to the log base 4, they would cancel and I could go on my merry way. And the fact of the matter is, I could rewrite 2 to the 8th power as 4 to the 4th power. So what I have here is 4 to the 4th power, or 4 to the power of 4 times log base 4 of 4. Now the base 4 of x, sorry, got 4 happy there. Again, if I had this right next to this, I could easily solve this. The problem is I don't. This other 4 out here, which is not an exponential base, it's a multiplication, is kind of standing in between them. If I can find a way to move that, I can deal with it. And we're going to be talking about momentarily a rule that's going to allow me to do that. So I'm stuck here for the time being. So we're gonna have a look at this in a moment and finish this one off. When I look at log base x of 5 and for f of x and g of x being 10 to the x power, again, if I'm doing f of g of x, I'm going to have log of g of x base of 5. So I'm going to have the log base 10 to the x power of 5. Now this is a weird kind of positioning thing, and I do believe they have an example like this in the textbook. I don't think even WebWork has a problem like this. At least I don't think it was WebWork that had a problem like this. How would you simplify this? I mean, it gets kind of complicated because, I'm going to let this be y for the time being. If I wanted to rewrite this as an equivalent exponential statement, I would say 10 to the x power, as my exponential base, raised to the y power would equal 5, which means 10 to the xy power would be 5. Which means if I wanted to figure out what xy was, xy would be the log base 10 of 5, which means if I want to get y alone, it'd be the log base 10 of 5 all over x. So that's how I would simplify it and get my final function. Because remember, I do want to have a function when all is said and done. This over here, just plain nastiness. We don't usually like having our variables as exponential or as logarithmic bases. But I guess that would be a good enough statement. But it's really more simplistic to have it look like this, because this would give you the exact same results. And honestly, so I can say that f negative 1 of x is log of 5 all over x.